Bismillahirrahmanirrahim to the lecture series on soil. This is we did the physical weathering in 2 lectures. Now this is the third of this series, chemical weathering, because soil weathering also, rock weathering also occurs through chemical means. Weathering is also termed as decomposition or decay of the rocks. Decomposition in a sense that it decomposes the rock. Physical weathering causes breakdown of the rocks. This breakdown is through chemical means, so this is also termed as decomposition. The rocks are decomposed, broken, changed, shattered through chemical process by causing chemical changes in the rock composition. So this occurs by chemical means. Therefore, besides reduction in the size of the particles from larger to smaller, there is a change in the chemistry of the product. So the weathered material is not only modified or changed into finer particles, smaller particles, but also it has changes in its chemistry. This process is termed as decomposition. During decomposition, new compounds are formed, which might be leached, washed away in solution or in suspension form, thereby decomposing the original material. 5 chemical processes accomplish chemical weathering: hydrolysis, hydration, carbonation, oxidation, reduction, and solution. I have written 5, but these are 6. So generally 5 are considered because hydrolysis, hydration, they are included sometimes in the solution, so we have separated them here. Hydrolysis. Hydro means water and lysis means decomposition. So decomposition change through addition of water. The reaction of the water decomposes the parent material through hydrolysis. Hydrolysis is an important process in chemical breakdown of feldspars, micas, aluminosilicates. It's a reaction between hydrogen ion and OH ion of hydronium ion of water. It is the attack of acid in water on mineral. In hydrolysis, cations that are part of the crystal lattice structure of aluminosilicate minerals, they are replaced by hydrogen ion and hydronium ion, resulting in distortion into hydrogen and OH ion. It then combines, joins with aluminum, silica, oxygen, OH on the mineral surface, breaking the SiO bond or ALO bonds. This process usually affects igneous rocks as they are comprised of materials that readily combine with the water. Hydrolysis, the common byproduct are H2SO4, HCO3, OH, cations, and cations along with the clay minerals under favorable conditions. The silicic acid formed is partly recombined with aluminium or further decomposed. A general reaction is given here. You can see that aluminosilicates plus water produces clay minerals, cations, OH, sulfuric acid, and bicarbonates. Hydrolysis, these are other examples. That is, orthos glass is hydrolyzed in a stepwise reaction solid KALSI 308 is changed into KOH solution and a solid material. The solid material further gains moisture or water, changes into kaolinite, and this again further decomposes into silicon dioxide and aluminum. Orthoclase is hydrolyzed. In this case, water-soluble potassium is released. It may be absorbed by the soil colloids or by plants or drained in water. We said in the beginning that it may be dished out, washed out, or retained or taken up by plants or animals. So in this case, you can see it is absorbed by the soil colloids, are used by the plants or drained in the water. The aluminum and the silicon compounds may be recrystallized into clay minerals such as kaolites. This is again an example. This is a reversible reaction. Hydration, dehydration. Whenever there is a hydration, gypsum calcium sulfate would change into hydrated calcium gypsum. When it is dehydration, it becomes anhydrous. Hydration occurs as a result of acidic solution. Water associates with mineral without actual decomposing or modification of the mineral itself. Hydration. It transforms feldspars to clay, dissolves carbonates. Dehydration is the reverse of hydration. An example of hydration and dehydration is the formation of gypsum and anhydrite by adding or removing water respectively. Hydration can be seen. In this case, you can see hematite Fe2O3 to limonite FeTO3 hydrated on hydration. The change is indicated by change of red color to yellow color. This red one is the hematite, yellow one in this case is the limonite. So this is again a reversible action. Hydration, dehydration, both are possible. If you hydrate, it becomes limonite. If you dehydrate, it becomes hematite. Third is carbonation and other related acidic series. Rainwater is naturally slightly acidic due to atmospheric carbon. Carbon dioxide is always present in the air. That becomes a part of the material, part of the, you can say, moisture in the air, and that becomes hydrated. So carbon, when joins moisture in the air or humid air, this process is known as carbonation. So this carbonated water, it dissolves limestone or chalk forming calcium bicarbonate. Rain has a normal pH of 5 to 5.5, which causes acidic chemical reaction. Carbonation is sometimes also called dissolution. Carbonation is effective corrosive agent, especially against marbles, marble tombs, marble structures. The solvent power of water increases due to the presence of organic and mineral acids. The solubility of calcium carbonate increases by 2 to 18 times with increasing carbon dioxide contents, maybe up to 100% of the atmosphere. It has been estimated that globally 37 tons of material per kilometer square is removed every year by carbonation or by carbonated water. The removed material is calcium carbonate, calcium sulfate, sodium chloride, silicon, alkaline carbonates, sulfates, magnesium carbonate, ferroxides, respectively, at a rate of 19,833 to 1.55 tons per year. This is a ratio, rough ratio in different parts of the world. this is happening. The presence of hydrogen ion in percolating water promotes chemical weathering susceptible rocks. That is, whenever hydrogen ion is present in percolating water or any water or even in the humid water, that causes weathering of rocks. Carbonic acid reacts on calcites forming soluble carbonates, bicarbonates. This is a reaction you can see that calcite plus carbonic acid, soluble bicarbonate is there. Carbonic acid reacts with calcites forming soluble bicarbonates as above given in the reaction. Air contains 0.03% carbonate, while rainwater may have 0.45% carbon dioxide in dissolved form. Air has less, rainwater has more. HNO3 and H2SO4 formed in the air by mixing of sulfur dioxide or NO oxides are stronger acids. These produce acid rains that decompose the rock and the minerals. So, any air having acidic nature because of solubility of sulfur dioxide or nitrogen oxides or carbon dioxide, that would be termed as acid rain. And whenever it comes in contact with the plants, human or rocky material or lime material, calcium material, that corrodes it. Formation of acid clay occurs in similar process. There is always differential response of mineral to carbonation. We have said in the very beginning that soil, rocks is composed of many minerals, and each mineral has its own peculiar behavior towards the various environmental factors, such as differential response towards temperature was there. So similarly, differential response toward acidity in the air or carbonation is also here. Potassium feldspar are resistance resistant. They resist this carbonation action of carbon dioxide or carbonated water, while hornblende is susceptible. This is weathering of limestone rock by chemical reaction. You can see the rock has been weathered, and these small grain-like structure, you can see bows-like structure. These are the weathered material. You can see the weathering has occurred because of the acidic water. This is a limestone rock in Pakistan, so weathering is going on. Fourth is oxidation. Rusting of iron or iron containing rock is the oxidation. So wherever you see on the rocks, if you are moving somewhere in the hilly areas, Swat, Dirkaghar, Badagali or Murray, you can see some rocks have rusted material. That rusted material indicates that oxidation is going on. Oxidation is occurring. This rusted color is the indication. As आयरन प्रेजेंट समवेयर जो लोहे को जंग लग जाता है वो ऑक्सीडेशन है. द टर्म ऑक्सीडेशन इन द कॉन्टेक्स्ट ऑफ simple weathering means a reaction with oxygen forming oxides. Magnetite exposed to air changes to hematite. Oxidation frequently occurs in rocks containing iron. So all those rocks, all those material which have which have iron in them, they would be subjected to oxidation. Oxidation is more effective in warm, humid regions. For the reason warm, that is the temperature, accelerates, promotes oxidation. Humid means moisture is needed. In dry conditions, even iron substances, they would not be oxidized, they would not be subjected to this process. But whenever humidity is there, अक्सर आप देखें कि जो छुरियाँ चाकू इस तरह की चीज़ें बेलचे होते हैं ह्यूमिड गीले होते हैं वो जंग पकड़ते हैं. सो जंग का होना मतलब है ऑक्सीडेशन इज गोइंग ऑन. Change of magnetite to hematite in the presence of air occurs as follows. This is again another example. Magnetite is changed into hematite because of oxidation. Oxidation is common in rock containing iron, more effective processes in warm humid regions. The surface color of Mars is also a good example of oxidation. This I added from some book that Mars shows a little bit reddish color, so that is because of the oxidation that in that planet oxidation is happening. Oxidation of olivine to serpentine and then from ferrous oxide to hematite are further examples. These two-step phenomena, you can say olivine is there, it is changes into serpentine and to ferrous oxide then further changes into hematite. Acid rain is the result of sulfur in fossil form to form SO3, SO2, SO3, and ultimately combines with the water making sulfurous acid and ultimately sulfuric acid. Acid rain is neutralized by carbonate bedrocks but remains acidic in surface and groundwater on granite rock. Acid mines drainage is the result of oxidation of pyrites, FeS2 to H2SO4 plus FeO3 limonite. So acid mine drainage because of oxidation change because of oxidation of the pyrite changes to sulfuric acid and to limonite. This is an example of oxidation. You can see this is a granite rock, and granite rock, the reddish part, you can see all this red or the yellowish one is the oxidized part. This is changes color laminite to oxidation. It is a mixture of iron oxide and mineral. This is a picture from Pakistani material. Reduction. Reduction is the opposite of oxidation. Oxygen is added or it is reduced. Bacteria can do much reduction. Reduction process is more is better way accomplished by or run by bacterial organism. Reduction of iron, ferric to ferrous, imparts characteristic green and blue colors to many reduced soil minerals. Organic matter is reduced by fermenting bacteria to sulfate, which is further reduced by bacteria to sulfite. Many silicate minerals contains cations of iron or magnesium are easily converted to another oxidation state. Solution. What is universal solvent? Acid enhances solvent action of water. Carbonates, oxides, chlorides of potassium, sodium, calcium, magnesium all are decomposed due to solvent action of water, simple or even acidic form. This is again, this picture I have shown previously to you also. This is soluble salt moving down in solution form due to physical and chemical weathering of the Bahadur Khel salt mines, Karak area. Thank you very much for listening and giving patience.